So next is inverse functions. And this is the definition of an inverse relation. Two relations are inverse relations if and only if whenever one relation contains element AB, the other relation contains element BA. Basically, what happens is the x's switches with the y's, and that's your inverses. And then for it to be functions, you can't have any repeating x values, or it has to pass the vertical line test. Same thing we did before. So to find the inverse of A has the point 1,5. And if B is the inverse of A, that means B is going to have the point 5,1. And A has the point 2,6. B is going to have the point 6,2. And A has the point 3,7. B is going to have the point 7,3. Switch your X and Y's. So we're going to look at this question, and it's a vertices of a triangle, 1, -2. So these points go on the graph and form a triangle. I'm going to find the inverse of this relation. So the inverse is going to be -2, 1, 5, 2, and -1, 4. So when I plot those points, and this is the inverse relation. What I want you to notice here is that these points reflect on the graph, but they don't reflect across the y-axis, they don't reflect across the x-axis. They reflect across this line that is y equals x, and it's going diagonally through quadrants 1 and quadrant 3, and see how this point reflects to this point reflects to this point, and this point reflects to this point. So if I folded it on that line y equals x and folded it on that line, the points should match up right on top of each other because they're a reflection across that line y equals x. So here's some property of inverses. The way you write the inverse of f of x is f raised to the -1. What that means is f inverse. And what that would be referring to is the inverse of the f of x function. If f and f inverse are inverses, then f of a equals b, if and only if f inverse of b is equal to, what that's going to be is a. And basically it's saying your x's and y's switched. Find the inverse of a function. We're going to go through some steps here, and I'm going to show you the graph. We won't graph much of it, but I do want you to understand how the graphs look compared to each other. So step 1 is going to be switch the x and y. And where is my y in this function? Where is f of x? So this is the same as y equals -1/2 x plus 1. I'm going to switch my x and y. So x equals -1/2 y plus 1. Just like when you were given the points and you were asked to find the inverses, you switch your x and y. So same thing with the function. Switch the x and y and then solve for y. So I have to subtract 1. I get x minus 1 equals -1/2 times y. And instead of dividing by -1/2, I'm going to multiply by its reciprocal, -2. You got to remember that I'm multiplying it with the whole side though, so I have to distribute it. So I get -2 times -1/2 becomes 1y, and -2 times x is -2x, and -2 times +1 becomes +2. I'm sorry, -2 times -1 becomes +2. So the inverse relation is y equals -2x plus 2. We can write that like this as well. F inverse of x, -2x plus 2. So to graph this, I'm going to graph the f of x function in red, and I'll have my y-intercept at 1. My slope is down 1, right 2, up 1, left 2. Double check it is a negative slope and draw my line. And I'll draw my F inverse in green. And I have my y-intercept at 2. And my slope is negative 2, down 2 over 1, down 2 over 1. And these are the two inverse functions. And if you notice, they reflect across this line y equals x. So to verify that two functions are inverses, this property says that if f of x and g of x are inverses, if and only if f of g equals x and g of f equals x. It's not equal to 0, it's not equal to 1, it would have to equal x. So if you plug one function into the other and it equals x, that means they are inverses. So to determine whether each pair of functions are inverse functions, explain your reasoning. So I'm going to try f of g, and I'm going to plug the g function into the f function. So I have 3/4 times, and I'm replacing this x with that g of x function, 4 over 3x plus 8, and then minus 6. So when I go to distribute this 3 over 4, that becomes 12 over 12, or the cross cancel like this, and that becomes 1x. This is going to become 24 over 4, and then minus 6. Well, 24 over 4 reduces to 6. 6 minus 6 is 0. So f of g does equal x, so it means they are inverses. And moving on to B. So this time I'm going to try g of f, and I'm going to use this one. So I'm plugging the f function into the x of the g function. So I have 1/3 times 3x minus 3 plus 4. Well, when I distribute this, 1/3 times 3 is 1. That's 1x. 1/3 times negative 3 is negative 1 plus 4, and that becomes x plus 3. Well, because it isn't x, and there is this plus 3 on the end, it means that they are not inverses. So here are a couple U-try problems. So find the inverse of this function and then determine if these are inverses or not by plugging them into each other, f of g or g of f. So now, pause it. So here are your answers. For the first one, to find the inverse, I switched the x and y, so I made this x equals y minus 3 over 5. And because all of this is being divided by 5, before I can do anything with that term, there's nothing else on the outside here being added or subtracted, I got to get rid of that 5. So I multiply both sides by 5. Y minus 3 is equal to 5. Add 3, and y is equal to 5x plus 3. So the inverse function of f inverse, is f of x plus 3. And to determine if these two are inverses, plug one into the other one, f of g. So I plug this whole function here into x, and I end up getting 2 times that square root squared minus 1. Well, the square root and square basically cancel each other out. So I'm left with 2 times x plus 1 over 2. And here, this 2 and 2 cancel each other out. So I'm left with x plus 1 minus 1, which is equal to x. So it works. It is equal to x, which means yes, they are inverses. And I also did it the other way here. I plugged this whole function into the x in the square root, and that goes here, and then simplified it. The negative 1 and positive 1 cancel out, so I get 2x squared over 2 all under the radical. The 2's cancel out, so I'm left with square root of x squared, and that is equal to x. So yes, they are inverses. So what do you get when a chicken lays eggs on top of a hill? Egg rolls! Rolling down the hill.